In this video, we will look at the application of a quadratic function in the context of baseball. The height of a baseball in feet, t seconds after being hit, is modeled by the function h of t equals negative 16t squared plus 75t plus 4.7, while t is greater than or equal to 0 and h of t is greater than or equal to 0. In part A, we need to answer the question, when will the ball reach its greatest height? Recognizing that we are working with a quadratic function, so in other words, we're working with a parabola, looking at the first term and seeing that it is a negative 16t squared, we can recognize that our parabola will be opening downward. So when we are looking for the greatest height, that is another way to say, we are looking for the vertex of this graph. In addition to being told that we're looking for the vertex, we want to note that the question is specifically about when. A when question is about the time. So not only am I looking for the vertex, I'm specifically only looking for the t value of the vertex. The first step in finding the vertex is to find typically the x-coordinate. In this particular example, though, we don't have an input variable of x, we have an input variable of t. So the vertex will be found by finding the t value first, and the t value will be found by setting t equal to the opposite of b over 2a. In our particular example, t will then be equal to the opposite of 75 over 2 times negative 16. When we put this into a calculator, we can approximate this value as 2.344. Had I been asked to find what the greatest height would be, I would have then substituted this value in for the t's in the function. But since that was not asked for, I'm not going to take the time to do it. I will simply answer the question. When will the ball reach its greatest height? The ball will reach its greatest height approximately 2.344 seconds after being hit. In part B, we are asked, when will the ball hit the ground? It is important to recognize a when question is a question about the time. What is the t value when this happens? What we're looking at is when the ball hits the ground. So if we're being asked about the time, we must be told something about the height. When the ball hits the ground, what will the height of the ball be? Well, when the ball hits the ground, the height of the ball will be 0 feet above the ground. So we are indirectly being told the height has to be 0 feet. More indirectly, we are being asked to find the horizontal intercepts. To do this, we'll set the function equal to 0. So we will set up the equation negative 16t squared plus 75t plus 4.7 equals 0. Since it has not been specified what method we should use to solve this equation, it is up to us to decide. In looking at the values I'm working with, specifically that 4.7 in the equation, I'm thinking that I will not go ahead and use factoring. Also, because of the 75t term, I will not use the square root property. So the only method I have left available at this moment is to use a quadratic formula. So to set up the quadratic formula, we will begin with t equals, and typically we would say the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So in our particular example, this becomes the opposite of 75 plus or minus the square root of 75 squared minus 4 times negative 16 times 4.7 all over 2 times negative 16. Continuing with some of the simplification, 75 squared is 5,625. Negative 4 times negative 16 times 4.7 is 300.8. In the denominator, 2 times negative 16 is negative 32. So we obtain the statement, t is now equal to negative 75 plus or minus the square root of 5,625 plus 300.8 all over negative 32. Bringing this back up top to give ourselves a little bit more room, we can now add 5,625 with 300.8 to obtain 5,925.8. So our t value is equal to negative 75 plus or minus the square root of 5,925.8 all over negative 32. At this point, we're going to separate this into the two possibilities. Either t is equal to negative 75 plus the square root of 5,925.8 all over negative 32. Or t is equal to negative 75 minus the square root of 5,925.8 all over negative 32. Putting the first possibility into my calculator, negative 75 plus the square root of 5,925.8 all divided by negative 32 is equal to about negative 0.062. On the other hand, putting negative 75 minus the square root of 5,925.8 all over negative 32 into my calculator, that value comes back as about 4.749. Now, it's not surprising that we have two solutions for this particular equation. The majority of quadratic equations that we've seen have had two solutions, but we were told from the beginning this function is only useful, it's only an appropriate model when the t values are greater than or equal to 0 and the h values are greater than or equal to 0. Of these two solutions, one of them does not fit into that. The t value of negative 0.062 does not fit into the restrictions that we were given from the beginning. It cannot be the solution, it cannot be the answer. If you think about what that would mean in context, where t is representing how much time has elapsed since the ball was hit, negative 0.062 would represent 0.062 seconds before the ball was hit, and that just simply doesn't make any sense. So the value we'll go with, as our answer, is 4.749. So to answer the question, when will the ball hit the ground? We'll say, the ball will hit the ground approximately 4.749 seconds after it was hit.